What is up, guys? Welcome back to the video. We got breakfast here, a matcha latte and some cinnamon banana bread. But I wanted to take a chance to thank you guys so much for watching the chemical engineering day in the life videos. And I figured I'd make a kind of follow-up video to answer all of the questions you guys have been shooting me in the comments about chemical engineering. I got some feedback that you guys wanted more of a detailed video asking actually what a chemical engineer does instead of just watching me eat stuff during the day. And to that I say, I'm still gonna eat stuff, but I'll actually show you guys what I do. And the reason that I haven't been sharing much is because of the nature of my work. I can't really share a lot of details of what I do, but I will try to speak in general terms of what a process development engineer does. So basically, as a process development engineer, you're the kind of chemical engineer that is working on new processes. So there's a process engineer and there's a process development engineer, which are two of the big roles in chemical engineering. So a process engineer, which is a role that I did at a pulp and paper mill, that is for usually existing processes, things that have been tried and true. Pulp and paper, it's not like you're reinventing the wheel. The wheel has been invented and you're thinking of different ways to keep your production high. So there's key performance indicators, and those are kind of like specs on your product that your customer needs, and you have to make sure that those specs are always in line. Otherwise you can't sell your product. So your role as a process engineer at a plant versus me as a process development engineer working from home is a process engineer works on solving problems in the plant, improving things that are already there. Whereas a process development engineer, depending on the stage of your company, you're thinking of things that haven't been done yet, and to basically create a new process that you think will be economical and that will improve the planet, basically. Okay, so what is process development? What is my job actually? There's like different stages in an engineering project. There's the conceptual phase, and then there's a detailed design phase. Basically, there's a conceptual phase, and then there's a detailed design phase, and then there's like running the plant. So a chemical engineer's role is usually in the conceptual design phase or in the running of the plant. And basically, when you're working as process development, you're thinking about the conceptual phase. You're thinking of things that aren't existing yet. You'll come up with an idea. Let's say you have a new idea to produce pulp and paper. You'll come up with the entire balance of plant, all the equipment that you'll need. How conceptual design works is first you think of, modeling it. You look at existing plants that have already done things that are similar. You'll run maybe economic analyses to make sure that your idea is feasible. And then you'll go out and do it at a small scale, which is kind of called like the lab scale production, where you'll prove like the chemistry works. If lab testing works all well, you'll go to the pilot phase, which is kind of like usually I think around 10 times smaller than commercial production. And then if pilot production works, you'll go on to commercial production, which is those large, huge plants that you see chemical engineers working at. So I thought that one of the best ways for me to explain, what a process development engineer does, I found a very similar role at Tesla called a chemical process development engineer in materials manufacturing. So at the Tesla plant, one of the responsibilities of a process development engineer here would be to develop schematics and detailed designs for novel chemical processing systems. And what that basically means is coming up with PFDs, process flow diagrams, and detailed designs would be things like P&IDs, which is piping and instrumentation diagrams for novel chemical processing systems, which just means new things. So second thing here is to interface with suppliers through concept development, system design iteration, procurement, installation, and acceptance testing. What that basically means is that you are designing a plant, and at the same time, you have to talk to suppliers to make sure that they have the equipment that you need to run your plant. So for a company like Tesla, they're doing more of the conceptual design work and the detailed design work, but you can't really have one company that does everything, right? As Tesla, they make these batteries, but they design all the things to work together. So you can't be a specialist at everything basically in chemical engineering. So you talk to equipment suppliers, for things like heat exchangers, things like compressors and separators. And as a chemical engineer, your job is to kind of act as the focal point where you're looking at what kind of equipment we need And then you're also talking to all these people to find the best cost, find the best product that works within your process, best efficiency, things like that. And as you gather this information from vendors, from equipment suppliers, you'll iterate on your system design. Oftentimes you'll start with something that thermodynamically makes sense. Maybe the configuration you have within your heat exchangers and separators was no good, and maybe that was a costly iteration. But if you flipped the configuration of the things within your plant, maybe that lowers the entire cost of things or improves the efficiency of your plant. Procurement and installment just means buying stuff, making sure it's installed properly, and then acceptance testing. I think that means when you get the thing, making sure that it's working within the plant properly. Third thing here is development of operating procedures, safety protocols, and maintenance plans for large-scale chemical process equipment. That just means that you have to develop proper safety guidelines for working with equipment. As a chemical engineer, a huge part of your role is safety, and a lot of people go on to specialize in process safety because it's a huge topic in engineering, making sure that we can identify risks, mitigate them, prevent them, and make sure that they're not even there at all. And that starts at the conceptual design phase. You want to design things that aren't really risky in nature in the first place. You'll avoid making toxic materials rather than mitigating how much you make, right? You want to prevent the things from being a problem before they are a problem. So coming up with operating procedures, SOPs or safety operating procedures as they're called, safety protocols and maintenance plans to make sure that you can work on equipment, shut things down and not, blow up the plant, and make sure that everybody who's working in and around the equipment in the plant is always safe and knows what to do in the case of an emergency. So this next bullet point here is to support operations teams with achieving productivity and material quality targets on pilot and commercial scale systems. We don't have a physical plant to work with yet, but for someone like Tesla, this kind of role is where you can maintain things as well as create new things, which is really cool that they have a kind of a mix of a process engineer and a process development engineer. So you would support operations teams by achieving the things that I mentioned earlier, things like production rate, specs, specific specs on your battery. I don't know much about batteries, but I know that, there are certain things and qualities you'd want in your battery. Maybe the material life of the battery. Maybe there's a, casing that you have to test on the battery to make sure it's up to spec. So also working with the R&D team for the introduction of materials and process methods at large scale. So basically what this means is maybe you're diving through literature, talking to universities and research groups to figure out new ways of an innovation within the process. So looking at maybe different materials, if your feedstock is this certain metal, maybe you could substitute it for a different, cheaper, more durable metal. And oftentimes there's like a pros and cons analysis that you just got to do on, a lot of different things. There's always a different option, a different way of doing things. And that's why a chemical engineer is so important at a plant is because you're supposed to understand, what's the payback on certain things in terms of cost, in terms of how it improves your product. And at the end of the day, your job is to make everything more efficient, make the company more money. And if you can do that, then you'll be a very valuable chemical engineer to have in the workplace. Building material and energy balances of plants. So that kind of takes us to the next question, which is, do you use your schoolwork in your job? And the answer is a little bit. Materials and energy balances from second year, I definitely use a lot. I've built mass and energy balance tables. I also use process flow sheeting a lot, which is making chemical process simulations to understand thermodynamics of a particular system design iteration. And then another thing here is to have good knowledge of common chemical processes. There's so many different ways of doing heat exchange, doing separation, just for one specific material maybe. There's like so many different options you'll have, but basically the basic chemical processes are separating things and heating or cooling things down, and that, and obviously reactions. If you have those three basics, you'll basically start to build your list of experience as you go on through more work and more work experiences. So I knew nothing about pulp and paper, but then I did that job in pulp and paper, and I learned a lot about digesters, bleaching towers, different separation methods. And just as you go through chemical engineering, I don't think anybody expects you to know every single process, but you should know the very high level things and then kind of start to build your list as you go through your work experience. So another requirement here is obviously that working with process simulation software. In third year chemical engineering, I learned about Aspen Plus. In fourth year, I learned about Aspen HYSYS, which are just two process simulation softwares, but there's tons of them out there. There's ChemCAD, there's ChemKin, there's DWSim. There's tons of things out there. I guess most people usually get their experience from this through the design teams or just through other projects that they do. So yeah, just make sure you have a lot of projects on process simulation on your work experience if you can. So CAD software is something that I see a lot in job resume application things for chemical engineering, which is weird because we never really had a course on this. So I feel like, I've had like one lab course. I've had one lab where we looked at CAD software and we tried to build this design part. But I don't know, it's just weird to me that we're expected to know 2D and 3D CAD, but I feel like most people learn this through design teams. Like we had Chem E car at UBC, which is a design team to make this little car that works off a chemical battery. And I'm pretty sure they had to use CAD to design parts. I don't think this is gonna go away as a requirement, so it's worth learning. But hopefully if you don't know a lot about it, the job will just teach you on the job. And then the last two things here are to read engineering drawings, which you learn through co-op experience and a little bit in your fourth year project. And then the last one is to think critically and innovate in a new role. And I think that that's very crucial to not only be able to answer questions that your boss or supervisor gives you, but to also be able to think for yourself and think if we're even asking the right questions in the first place. I find that oftentimes the question isn't even well defined like it is in schoolwork. Oftentimes you've got to figure out what the question is and then answer it, and then figure out if you even answered the right question. So I think the last thing here that I would say is missing as a requirement is your ability to communicate effectively and be an engaging speaker. I've found that working at a startup, it's not enough to be able to think critically and to be able to solve problems. You also have to be able to communicate what the solutions to those problems are very effectively and concisely, and to make sure that people actually understand what you're talking about. One time I had this presentation I had to do on this market research topic I was looking at, and I wasn't able to effectively communicate that information with my team. And even though I knew it in my head, because I wasn't able to communicate that time very effectively, understanding something in your own head is really only the first part of understanding something. Being able to communicate that, being able to answer questions about that related to other things is super, super important as a chemical engineer. You'll hear it over and over again. Your ability to communicate is crucial to your success as a chemical engineer. I've heard it from my chemical engineering mentor that I've had right now, who has 20 plus years of experience in the field. Yeah, anyone you ask will tell you you have to communicate with lawyers, maybe with operators, with people working in the plant, with engineers, outside consultants, your supervisors, everybody you meet, you have to communicate effectively with in order to get the job done. That's a huge thing. I've been starting to look into more Toastmasters meetings to think about how I can improve my public speaking. YouTube has also been great for this. I think that I get a lot of good practice in just speaking and trying to be concise and not ramble off like this. And I've also been tutoring on the weekends, which really helps for me to think about not only how I would solve the problem, but explaining how I would teach a problem has been great for me. I was gonna do a day in the life video, but I've been talking for so long. I think that that's enough content for this video. So thank you guys so much for watching, and I really appreciate all of the comments you guys have been sharing in my videos. I think I've answered most of them, but I'll try to get to the rest of them today. I hope you guys stay tuned because we've got lots more videos on chemical engineering. And on other stuff that I feel like making videos about, a couple of things I've got lined up are advice for chemical engineering students, my path to a chemical engineer so far, internships that I've done, what school was like, and what my plan for the future is, and then miscellaneous topics like career paths in chemical engineering, skills, and anything else that you guys want to see, drop it in the comments below. I'll try to get to all of it with a reply if I can't make a video on it. I really gotta get this workday started. Yeah, I'll see you guys in next week's video. Thanks again for being here. Thanks again for subscribing, liking, watching the videos. I really appreciate it.